This is Basic Algebra Week 8, Part 1 video, rewriting standard form equations in slope-intercept form. Our example is, consider this equation 2x plus 3y equals 6, which is in standard form. We want to solve the equation for y to put this into slope-intercept form. To do this, we're first going to subtract 2x from both sides. Doing this gives 3y equals negative 2x plus 6. Then, we're going to divide both sides by 3, since we've isolated the variable 3 and y. And doing so gives us 3y divided by 3 equals negative 2x plus 6 over 3. Now, we know from our work in previous weeks that we can split this fraction up to get y equals negative 2/3 x with the minus sign out front, and then 6 divided by 3, which is 2. This equation is now in standard form, and we can graph this using the methods we've just talked about. So number 2, we want to choose points. These should be multiples of 3 this time, because our denominator is 3, and we don't want any fractions or decimal values. If we make a table for this, we could choose the points negative 3, 0, 3, and 4, and substituting these values into this equation will give us 4, 2, and 0. You should check that and verify that with a calculator. If we draw and label the line, we find that we have negative 3, 4, 0, 2, and 3, 0 lining up. We draw the line completely from end to end with arrows and as straight as possible, and label the equation 2x plus 3y equals 6. So that is how you solve an equation that's in standard form and rewrite it in slope-intercept form and then graph it. We're going to move on to a very important topic called the slope of the line. We've pointed out in class several examples that involve slope when we were talking about slope-intercept form. This goes into more depth. The slope of a line is a measure of the inclination or steepness of the line. To find the slope of a line, we first let P of x1 and y1 and Q of x2 and y2 be any two distinct points on that line, meaning that they're different from one another. The horizontal change, or the change in x, is gotten by subtracting the x points. So we take x2 and we subtract x1 from it, where we've gotten x2 and x1 from our points. The vertical change, or change in y, is between the points y2 and y1. We take the y values, y2, y1, and subtract them in the same order, y2 coming first. In our graph, we can see that point P of x1, y1 and Q of x2, y2 are on this line. The horizontal change is what we get is this distance right here, gotten by subtracting x1 from x2. The vertical change is gotten from subtracting y1 from y2, and they would actually meet at this point, which is x2, y1, but that's not important. What's important is the fact that these two pieces of information are related to an important concept called slope. We call the ratio of the vertical change, y2 minus y1, to the horizontal change, x2 minus x1, the slope of the line as we move along the line from P to Q. Here's a definition of slope from the textbook. If P, x1, y1, and Q, x2, y2 are 2 points on a line, then M, the slope of the line, is given by M equals vertical change divided by horizontal change, or y2 minus y1 divided by x2 minus x1, where x2 and x1 can't be the same because otherwise we would be dividing by 0. This formula we're going to use the rest of the term to do a lot of different calculations and graphing methods with lines. First of all, let's find the slope of a line. We're given 2 points. We want to find the slope of the line containing points with coordinates 1, 2, and 5, 4. Let P x1, y1 be 1, 2, and Q x2, y2 equals 5, 4. The order doesn't matter, and I could just as well switch these, but we'll stick with this for now. By the definition of the slope, we have M is y2 minus y1, so that's going to be 4 minus 2, which is 2, over x2 minus x1, which is 5 minus 1, which gives us 4. That's 2/4, which reduces to 1/2. So we would say, from our diagram here, that the slope of this line is 1/2. And that will have an even more important meaning as we move into the next chapter. The line has a positive slope. It rises from left to right. We always read our graphs from left to right. So what you should do here is find the slope of the line containing points with coordinates 2, 3, and 5, 5. Stop the video, and after you've finished your answer, then you want to start the video again and check the result. Our result is this. We're going to subtract. Again, we'll call this our x2, y2, and this point 2, 3 our x1, y1. So we're going to go 5 minus 3 and 5 minus 2, which gives us 2/3. And again, this line has positive slope. We would see that if we graphed the points and drew the line, that it rises from left to right. Finding the slope of the line. Second one. Find the slope of the line containing the points with coordinates 1, -2, and 3, 6. Let P of x1, y1 be -1, -2, and Q of x2, y2 be 3, 6. So, by the definition of the slope, we have 6 minus -2 over 3 minus -1. Again, then what will happen is this will become addition, so we get 8 over 4, and our slope is 2. So you'll see again that the slope is positive, and in fact, the line is rising from left to right. We can also compare the slopes of lines, and that will be important for our work as we go forward. The slope of line L2 contains the points -1, -2, and 3, 6, and its slope is 2. We just completed that problem. If we go back to the problem we did previously, the slope of line L1 containing points with coordinates 1, 2, and 5, 4 was 1/2. If we look at these visually, we'll see that the two lines have very different slopes. The 1/2 has a much more shallow slope than the line L2 with its slope m equals 2. When the value of the slope is positive, the line rises from left to right, and as the value of the slope increases, the line becomes steeper. A slope of 2 is much steeper than a slope of 1/2. Finding the slope of the line is easy to do even if we've just given the diagram, and we can continue with this example. Here we have -2, 3 and 1, -3. By the definition of slope, we have that -3 minus 3 divided by 1 minus -2 gives us -6 over 3, or -2. So you'll see with this line falls from left to right, or decreases. So its slope is negative. A negative slope is a line that falls from left to right. Here's an example you should try to see if you can find the slope of the line. Start the video again after you've completed your calculation. In this case, the slope is going to be -3 minus 3 divided by 1 minus -1. Be sure that you don't reverse the direction in which you subtract. In other words, always take the first value from the second point, and then the second values from the first point. We get -6 divided by 2, which is -3, and again we'll find that our line falls from left to right. We also have horizontal and vertical lines. An example would be, we want to find the slope of a line containing points with coordinates -5, 2, and 3, 2. By definition of the slope, we have y2 minus y1 over x2 minus x1 is 2 minus 2 over 3 minus -5, which is 0. We already know that these points, -5, 2, and 3, 2, from our previous discussion, form a horizontal line. So now we can see that a horizontal line has a slope of 0. We can also find the slope of a vertical line. Finding the slope of the line containing points with coordinates 2, -5, and 2, 5. By the definition of slope, we have 5 minus -5, which is 10, over 2 minus 2, which is 0. We could already see from our previous work that since the x-coordinates are the same, this is going to be an equation that represents a vertical line. Here we find that this value, since we cannot divide it by 0, is undefined. We say the line has an undefined slope. It is vertical and has no defined slope. So if we picture this, remember that a vertical line always has an undefined slope because we would be subtracting the same x value and dividing by 0. We can also, given a line, find the slope just by inspection. The most frequent way to do this is to find the x-intercept and the y-intercept if they are at exact coordinate values, as they are in this diagram. Find any two points at exact intersections of the line with the grid. In this case, 3, 0 and 0, negative 4, the x and y intercepts. So, once we've located those points, 3, 0 and 0, negative 4, we simply subtract and divide. So I'll have negative 4 minus 0 divided by 0 minus 3, which is negative 4 divided by negative 3, and that's 4/3. So it's a positive line which rises from left to right, which we can see from the diagram, and our slope describes that. Here's an example to try on your own. See if you can figure out what the slope of the line is. Stop the video, and after you've completed your calculations, start it again. For this example, we have two given points. This is the point 1, 2, 3, 4, 5, negative 5, 0, and this is the point 0, negative 2. So our calculation yields negative 2 minus 0 over 0 minus negative 5, which is negative 2 over 5, or negative 2/5. Clearly, this negative slope represents this line which falls from left to right. Here's a summary of slope that will wrap up our short lesson. The slope of a line that rises from left to right is positive. The slope of a line that falls from left to right is negative. And the slope of a line that is horizontal is 0. This vertical line has undefined slope. And that completes our lesson about slope.